So today we're learning the 5 different ways to solve a quadratic. We've seen all 5 ways before. None of this is new material. This will be review only. Yes?
Why are we reading?
No. Just, we're going to have a quiz soon, yes. But it's just a really good place to try and bring it all together. Because they all solve the same type of thing.
I have a question. When we write the notes, do we write it like set up and then
Yes.
so
Yep.
exactly how it uses?
Yep. Except each page of mine is the box you'll be using. Possibly. You will have to
Why am I
write small.
writing down graphically?
If you really don't want to use the box, you could use your own piece of paper.
Oh yeah.
Okay. I did just like the way this is set up. But if you feel like you're going to run out of room, using your own piece of paper is fine. Okay. So graphically, we have to have things set up a certain way before we can solve these problems. So graphically, we need to be equal to 0. That's how a lot of them should be set up. Not all of them, but a lot of them. So a lot of them have that same way to set up a quadratic. So when we are solving graphically, our answers should also look a certain way. We need to know how we should start and how we should finish. So that's what I started with. We should start with being equal to 0. We should finish with 2 answers. X equals some number and x equals some other number. Okay. That's how our answer should look like. So not hashtag. That symbol also means number. Meant number first. So I've started with an example now. X squared minus 2x plus 1 equals 0. And if we're going to graph this, then we need that formula, negative b over 2a. What does that formula remind you of? Negative b over 2a should sound familiar now. Where have we seen something similar?
Quadratic formula.
The quadratic formula. It just doesn't have the square root part. It is. That's exactly where we got that information from, was the quadratic formula. So, we need to identify a and b before we can use the formula. A is the number in front of x squared, so we do have an x squared, but nothing written. So that means a is 1. Jesus is correct. What about b? Negative 2. Remember, we don't want the x with it. We're just looking at the number in front. So now we plug these into the formula. It's very similar to the quadratic formula, except a lot less is going on. So we have negative b. What do I replace b with? Okay. The negative 2. b was the negative 2 over 2. Now I use a. What was a? 1. So we simplify. Nicholas said, hey, that's going to be 2 over 2. Yep, because a negative outside a negative is just a positive. 2 times 1 on the bottom is 2. So that gives us a value of 1. That was the x-coordinate of our vertex. We're going to need some space for the y-coordinate, so leave a little bit of space. But then we can say the vertex starts with 1. We have found the x-coordinate of our vertex. And this is something we did about 3 or 4 weeks ago. It was close to the end of last quarter, but not super close. So we found the x-coordinate of our vertex. We still need a y-coordinate. what did we do to find the y coordinate of our vertex?
Using the box method?
Okay. No. Okay, Liam.
I'm taking the answer from the x coordinate, put it back into the equation and replace it with all the x.
Okay. Take the x coordinate and replace it into all of the x's. If we know what x equals, I can replace it. So we would have the y coordinate is 1 squared minus 2 times 1 plus 1.
And then we solve that.
And then we just solve it.
It's the same thing. It's one, right?
No. It will not come out to be 1.
No, not
We
one,
do
like
1
it's
squared
that
first.
way.
What is 1 squared?
Like,
1.
problem.
Negative 2 times 1. Negative 2. And then still plus 1. Then we just add it all together. 1 minus 2 is negative 1. Plus 1 is 0. So we have 1 comma 0 is where our quadratic starts. That's our vertex. So we know our vertex. We still need to know our slope. What was our normal slope pattern?
1 over 1, 4 over 2.
1 over 1, 4 over 2. It's been a while, so not all of you might still have that memorized. 1 over 1, 4 over 2. So from this dot, we go up 1 over 1. So from here we counted up 1, and then right 1, put our next dot. So again, from here we had to count up 1, right 1, put our next coordinate. Up 1, left 1, because we know a parabola repeats on both sides. We go back to the beginning, now we do up 4 over 2, up 4, left 2. So our answers should look like that. And I should have also been a little more specific on the answer part. It's where we cross the x-axis. Where the parabola crosses the x-axis. So looking at our picture, where does our graph cross the x-axis? I'm going to someone up front say it. 1, 0. Now, when we get our answer, we're trying to find what x is. So we just need the x value where we cross the x-axis. So what's our x value of that coordinate? What's our x value? 1. So we get an answer of, did I move up too fast?
Yeah.
So we have our answer. Now the problem is, most of these methods only work some of the time. We need to know when it's going to work, especially for our homework tonight. On the homework, I'm taking one problem and asking you to do it all 5 ways. Sometimes those ways will fail. So on the homework, you've got to know, when does this method not work? Okay, so this method works if we cross, or I should say if the parabola crosses the x-axis at an integer. If we're too far away, maybe we won't be able to tell where it crosses. So if we're too far away, it's going to fail. If we do our slope and we don't get one of our points actually on the x-axis, it's going to fail. We'll get a general idea of where it would be, but we won't know exactly where it will be. So that was our first method. Second method. What's our second method that we're going to be working with?
Square root.
Square roots. Does everyone have this written down before I move to the next page? Yes?
Wait, so wait, when you move to the next block? Oh, okay.
Okay.
What?
Maybe. Come on. Okay, square roots. Solving by square roots is very, very limited. This one's the nicest one to tell if it fails, because we don't have to do any work to know if it fails or not. The other ones, we might have to go halfway through the problem and then say, oh, this one fails, I can't continue. This one, right from the beginning, you should know if it fails or not. So, to use solving by square roots, instead of having to be equal to 0 or having to have variables in a certain spot, our only thing we need to be concerned about is that we have no x term.
Which means there's no number in front of us.
Which means there's no x written at all. There is an x squared still written, but no x written. So we don't have an x written at all, or it doesn't matter which letter you're using, whatever letter we're using, there's no x term, no middle term. Again, our answer should say x equals some number. And when we solve this, we just need to solve this using opposites. If you can remember which one this is, it should be one of the easiest ways to solve because you learned how to solve equations pretty much all last year. So hopefully you've gotten a lot of practice at that. So if I'm going to solve this just like I would any equation you worked with last year,
Plus 7.
okay, we need to plus 7 first. We need to do our opposites.
You need to do that to both sides.
What you do to one side, do to the other. Okay, so next step, how do I get rid of the 5? Okay. Divide 5 on both sides because that was 5 times n squared. We're doing opposites, so the opposite of multiplying by 5 is dividing by 5. So we divide by 5 on both sides. We get n squared equals 4. And then I have to get rid of squared. This is our only new process. So, did everyone hear what Taylor said? Square root. Okay? The opposite of squared is square root. So we need to square root both sides. They cancel each other out on the left. I need my new symbol, and every time I square root now I put plus or minus. And then if I can simplify, I do. Now square root 4, you might recognize 4 as a perfect square. If you don't recognize 4 as a perfect square, we can still do our factor tree. So, if I factor tree 4, what are the only 2 numbers that multiply to 4 that don't include 1? 2 times 2. Those are both prime. So we have one group of 2. One guy dies, one guy makes it outside the square root. It's very squished. Let me redo that. And what happens if there was nothing left under my square root?
0.
Okay. We just knocked down the square root. Remember, no one's left in prison. We don't need the prison anymore. Get rid of it. Technically, it's a 1, but we just get rid of it. So again, this only works if there's no x term. That's the first box I would do on every problem. I'd go through because if there's no x term, I can immediately say, hey, this method doesn't work.
The only right in the
Yes. our next method was factoring. What do we really mean by factoring? When I say the word factoring, what method do we use to factor something? Box method. Factoring means the box method. Does everyone have this box written down before I move on? Yes? Okay. So when we are factoring, our setup is, again, our quadratic needs to be equal to 0.
These ones will do what?
Is this what? Homework? Yes, because the box method, the box itself just takes up a lot of room. So again, we have to be equal to 0. Also, when we're factoring, we really need whatever number is in front of x squared to be positive. We want it to be positive. Again, we want to know what our answer should look like. We should have x equals some number, x equals some number, and then I've given an example that we're going to use to practice factoring. So we said this had to be equal to 0. So what should I do to make that happen?
Bring the 5 over to the other side.
Okay. Bring the 5 over to the other side. We need to know how. So Michael, how should I bring the 5 over to the other side? Not Michael. Okay, there's 2. We have to do the opposite. Plus 5 to both sides. We had to do the opposite. I also have to move x squared. Same idea, I have to do the opposite. So Valeria, what should I do to move x squared over? I can't hear you because there's a little bit of talking. Sorry. Okay, square root is the opposite of squared, but we're trying to move the whole thing, not just get rid of the squared. So if we move something, we need to always do add or subtract. So let me see, because I had asked Valeria, but it was too loud. So Valeria, subtract. We do need to subtract. And I'm lining it up with its like term. If there's no like terms, it won't combine. This time we have all like terms, so we can combine everything. We know the right side is 0. We subtract down. 2 minus 1 is 1x squared. I can just write x squared. We bring down the 10x. Plus 25. Tell if you're awake or not. Okay, so now we need to do box method. Now we have to go back to what we learned when we were factoring. Okay. So, box method, we multiply first times last. 1 times 25. That's 25. Will,
Sorry.
what numbers will multiply to be 25 but add to 10?
5 and 5.
Is she right?
Yeah.
Does 5 times 5 multiply to be 25?
Yes.
Does 5 plus 5 add to be 10?
Yes.
So is Taylor correct?
Yes.
Yes, she is.
Yes.
Okay, 5 and 5. So then we set up our box with our first term, our last term, and the factors we found. and we greatest common factor once we have the box set up. So if there's ever a 1, our greatest common factor will be 1. So our first row is 1x squared and 5x. What does that mean? Our greatest common factor has to be 1. And if they both have x's, we include an x, so 1x, which is just x. So the first row is just x. What about the second row? What divides into both numbers? 5. Then we go down. When we go down, we're going to get the same thing. Now, normally we would write this as x plus 5 squared. But since we're doing a factoring problem, I want to write them separately so we can see the next step. So we write x plus 5, since this was between the x and the 5, was positive, equals 0. So even though we could write it as x plus 5 squared, I'm going to leave it as x plus 5 times x plus 5. Then we had to do something with this. Anytime we ended up with 2 parentheses, this was where we had to do our t-chart. And split it into 2 separate equations. So I'm going to give you guys 2 minutes to solve, maybe even just 1 minute, to solve these 2 separate equations. Okay, can I have your attention back up front? We got 2 answers. Stephanie, what did you get for the first one? What did you get for your answer here?
And still get an A.
If we get rid of this, we have to do the opposite. -5. Because if we minus 5 from both sides, 0 minus 5 gave us -5. Okay. What about on the second one? -5 again. Now, it won't always be the same. It just happened to be the same because when we factored, we got the same factor. Okay? This will only work if the quadratic will factor. If you go through and you cannot find any numbers that multiply to be what you got when you did first times last, and add to be the middle, then it is possible for it to fail. Wake up, we're on to the next box. Kevin, wake up, we're on to the next box. Okay, next box is completing the square. Austin, stop being weird. Okay, completing the square. This is something we did a little more recently. So hopefully it's a little more fresh in your memory. Yeah. So completing the square has a very different setup from everything else. Completing the square should have all the variables on the left, all the numbers on the right. Okay. And we could also say we have to put in the blank spots. And then we have 2 possible ways to write our answers. We'll either say x equals some number plus or minus some square root, or we learned how to simplify and combine if we could and get 2 separate numbers. So again, this is not what we did last time, but 2 times ago. So it's a little more recent. So hopefully, again, it's a little more fresh in our memory. So we have x squared minus 6x plus 7 equals 16. And it's not yet set up the way we want it. It's almost set up the way we want it, but not quite.
Is that supposed to be x squared, x equals negative number?
No, just x equals number. This right one, I just wrote my sign really long. I mean, it could be a negative, but it doesn't have to be negative. So it's just whatever you get when you solve.
I just remember
So we have x squared minus 6x plus 7 equals 16. And we have to get it set up the way we want. So we wanted all the variables on one side, all the numbers on the other side. So right now we do have all the variables on one side. What number is in the wrong spot?
7.
7. So we need to move it to the other side. And then this was where we had to put in the blank spots ourselves. We have to put in that blank spot. That is 9 plus. It looks kind of like 9t. Let me fix that. So then we could find that number in the blank spot and then do the box method, but we found a shortcut. We said, I don't want to have this be that long. So we found a shortcut, and that shortcut followed a certain pattern. We had to do the same thing every time to use this shortcut. We took our middle number, divided by 2, equals -3. And that did not go in our blank spot. It went in our perfect square binomial. Again, that was a shortcut. It just was so it made our life easier, so we found the pattern to make things go quicker. And then how did I get the number that goes in the blank
9.
spot?
Much better.
9. How did you get 9?
Because 3 times 3 is 9.
-3 times -3 is 9. -3 squared is 9. What you do to one side, you do to the other. So we got x minus 3 squared. The other side, I can actually combine these. 9 plus 9 is 18. And now I go to opposite operations. Now it's kind of like solving by taking square roots, because we do have to take a square root. The only way to get rid of squared is square root. No. Austin, refocus. We're almost done. We square root both sides. The square root gets rid of the squared, and if the squared is gone, I don't need the parentheses anymore. The only reason we had parentheses is because of the squared. I always have to put plus or minus. And then I need one more thing to get rid of the 3. I want x completely alone. So we add 3 to both sides.
There's 21.
Okay? Be careful. Why should this not be 21? We have to be careful.
It's 20.
They're not the same thing. So, if they're not the same type of thing, I can't combine them together. I just rewrite them side by side.
Oh, okay.
So you do have to be careful. Then, anytime I see a square root come up, I do want to try to simplify. So we need to simplify square root of 18. What are some numbers that multiply to be
9.
18? 2 and 9. Could have done 3 and 6. 9 is 3 times 3. So we get 3 times 3 times 2. 1 dies, 1 comes out front. I did go through that process fairly quickly because we've been doing that process from the beginning of the year. And then everything else that we did not touch just comes down. X equals 3 plus or minus 3 square root 2. So again, we need to know when this works. So technically completing the square would work in every single situation if we had talked about all the situations. But as a class, we've only focused on one type of situation when completing the square works. Next year, you'll learn how to work with every single situation. This year, we're focusing on one type and one type only. the number in front of x squared is a 1. Oh, and I should not have put my period there because the x term is even. All right. And again, technically it works in every situation, but there's only one type of situation we know how to work with right now. When there's the number in front of x squared is a 1, and the x term is even. Okay, our last problem was the quadratic formula. We're not going to do an example with the quadratic formula, but we are going to talk about what your answer should look like, what your setup should be. Austin, please stop. Okay, does everyone have this box down before I move to the next one? No? Okay. So while people are finishing up this box, so again on the homework, you're only going to have 4 problems, but those 4 problems you have to solve all 5 different ways. Not all 5 ways will work with every problem. Sometimes you might go halfway through and say, like with factoring. Factoring, you might go through and try to figure out numbers that multiply to be the first times last and add to be the middle, and it might just not work. So some of them you're going to write fails. It doesn't work. Something like that. Either halfway through the process, completing the square, you could identify at the beginning. If your number in front of x squared isn't 1, you should say, this fails. I can't complete the square because we don't have a 1 in front of x squared. No, sometimes multiple ways will work. Just most of the time, not every way will work. Okay, so last one is quadratic formula. Again, we're not going to go through an example. This is all you're going to have in your box. Quadratic formula. Again, the setup is we must be equal to 0, which we practiced. Our answer is going to be the largest answer out of any of them. Either number plus or minus square root divided by a number. And right now, that's what your answer will look like. We still have not talked about how to simplify a quadratic. We will, but we have not done that yet. So the or will not happen on the assignment. For the assignment, this is what your answer should look like. And then you need that quadratic formula, negative b plus or minus square root of b squared minus 4ac all over 2a. Again, you should memorize that eventually. If the music helps, go listen to the YouTube channel and listen to the song until you get the song memorized. And the quadratic formula works every single time. Every single problem you can solve using the quadratic formula. So every single box on your homework, you should be able to fill in with quadratic formula.